Okay, so I clicked the button. I completely forgot where we were.
What the
Uh,
I
fuck? You sound like me, man.
I just remember that we did some type checking functions to check each one of application, abstraction, and blah 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 or something like that. I also remember this where we made our own unique function because the OTP version that we are using does not provide this. Um, so we need to remember where we stopped.
Oh, that was very trash.
No, I seen worst.
No, that's
I've
very
definitely
trash.
seen worst.
Wait, man. I also opened Visual Studio. Well, Visual. Yeah, Visual Studio Code.
I think it was here.
Visual enslavement.
Type
Yeah.
check abstraction. So we are following
Then...
Nathan's algorithm, I guess,
That's not how it works, man.
Nathan's
to
algorithm.
to type check if the abstraction is fine, and the remaining
Yes.
step is this apparently, like this.
In the parameter.
Let me
I don't
see.
even remember what we were
First
doing, man.
works okay.
We
When
are
the
type
parameter
checking the
is
abstraction.
variadic.
So,
No,
following
I
my...
know that, but I don't know what is the logic that we were doing.
Let's
It
try
needs
to
to
read the.
have the list type
Oh,
on the
this is for
function
checking
body.
if the unique labels are equal to the length of the actual labels.
Wait, guys. Something else. Are we already checking if we have like duplicates on the names?
That's what we are doing this if.
Oh, okay, okay.
Yeah.
And then if we don't have, then we're gonna do this. And if we had a duplicate, we're gonna do this.
Oh, hey, Lemos. The thing about the
Okay, we
comment, it's because
and what we're doing
how
inside.
can I say it? Like you have the last argument, right? And it is the variadic one, but that's the thing. You will put like, oh, rest, and it's variadic, and it's a int, right? But inside the body, it needs to be a list, right?
Okay.
So we need the list type, like anyway, even if it's only built in, but the user cannot define it, right?
Wait, let's go one step, I don't know, one step back, not because I need to remember the logic overall.
Wait, Magetta, can you just tell me again the extension because white
What do you mean?
white text, man.
Oh, can you see my screen?
Oh, yeah. Mm, okay, holy. I have to install it all, right? Just
No,
to be
just
sure.
Yeah.
the first four ones.
Yeah, just install
Uh,
Flutter. Who cares?
no, that's what I'm talking about, Len.
And there's not that
uh,
many.
but let me see. This one, Erlang
Uh,
formatter,
okay.
Erlang one.
Oh, I remember this. We are also changing the logic of the AST now, and this will probably.
I think
Uh,
I already changed that.
no, but we
The
changed it
tests
again
are
here.
broken.
No, the wait, I don't
In
remember.
here, where, man?
This, this is like the types. You see, I don't think the labels in here they contain the type that they like. They're the type information.
Where is Lemus?
The labels, you mean
Oh, wait, Lemus,
the
you are reading only
function
for some reason, man.
abstraction. Yeah, they don't.
I am.
Yeah.
Yeah, I am only read only. That's fine.
Wait, can I write? Yeah, you are the one.
I remember allowing you to write.
I
If you
also
wanna join
remember.
again, if you wanna join again,
Wait. Can't I change this from here? That's stupid.
yeah, that's very stupid. Can I
Marcos
make read
Tarsuki.
only? Make read and write. Oh, that's Benny.
Oh,
But why Tarsuki?
yeah, nice. Now I can.
Uh, I don't remember, but I think it's because of a book.
Oh, I was expecting anime stuff.
No, man, anime. Benevides anime, man. That's like weeb stuff.
No,
No,
yeah,
man,
that
no, but
that's
Benevides is
fine.
the one that I wouldn't be surprised because he's so. I never know if he's serious or not. So anyway, My point is this thing. You can see that we are grabbing labels and mapping it to something else. In this case, we are also
Wait.
calling unique, but that is basically doing the same. So this is extracting the label itself, and
Oh,
this is extracting the type. But as far as I remember, the labels don't have this
No, they
information.
don't. They don't.
with information?
The type.
The type. You just add it there, man. Who
Yeah, no, we're
cares?
gonna add it later. I'm just remembering stuff. So these are grabbing the unique labels.
No, wait. These labels here that I mean, they are the types and the names, right?
Now they are, but we need to change that like retroactively.
Previously, they weren't.
Yeah,
They're just the
previously they
names.
weren't. Yes.
Oh, okay. You mean in other places, right?
Yeah, in the eval.
Yeah.
Oh, shit.
Yeah, but anyway, that was part of the plan. I remember. Then
Okay, so let's just go. I will assume this is done. Uh, type check an application. An application.
Oh, we hadn't finished that.
Let me just see what we've done. We did for abstraction, for a condition, and that's it. I mean, for a literal is stupid, right? You just spit the thing. A variable. A variable, it's kind of tricky because you need to get from the environment, right?
Oh, let me follow you.
Yeah, okay. So we're liking a variable and the application only. Is that right?
I think so.
The do you want to do the variable first? Because I think it's just getting from the environment.
Yeah, it's just so fucking easy.
Yeah, let's do that.
I don't believe type check abstraction is finished though. I think we are missing
Yeah,
this
so
step
so
here.
check it. So type check
Wow.
it. Because we already see, let's see, if in case if this is true, we get the accumulator, then we just put the thing in the map, and then we do new environment, which is the fold of this shit with environment plus labels. Then we do return type, which is the check, recursive check again of his environment with all the types of the things with the body. Then after that, we just spit that this
Mm.
thing is a function with a variadic info, types, return type.
Hey, Lemos. It's because we need to do some other stuff, like adding list itself to our language in order to finish the abstraction thing because of the variadic. Like we would need to create an expression for it and a type for it, right?
Why we need that in the language, like in Silverware, instead of using the built-in Erlang one?
Oh,
I'm confused. Why we need a list if it is variadic or not?
uh, how can I say? Like it's because inside the function body, it will be a list, right? So there is a list in the language. That's what I'm saying. Like we need to build a list in our language.
Oh,
But what if the language is a list? Boom.
Wow, then you have more powers, but doesn't change the the need.
okay. We can go back to this later. Let's do the type variable thing.
So
And I
we
just
just
noticed. I think I'm gonna have to enter the session again because I can't see the modifications that Magetta is doing.
what the
Holy, you
dude?
are really cursed today, man.
Yeah, man. I
As
changed
always.
here, like I toggled there, but
No,
anyway.
no, that's fine. That's fine. Just continue writing. I will be there.
Okay, so let me see. We want to get the type out of the type check with the environment. Oh wait, read them right.
Mm,
Try now, limbs.
yeah, now I can see. Now I can see. Nice.
Okay. All right, so let's think here. So we want to get the variable, get the literal value of it. We are not gonna allow like definitions of variables without any binding, are we?
Hmm?
Like in C. like int e. Like we're not gonna allow this.
Uh,
Wait. Can you
uh,
repeat from me,
well,
Magenta? What is
alright.
the procedure to type
Mm,
check a variable?
You get the variable in the environment, and then there will be the literal, and then from the literal you just evolve. So this is wrong.
uh,
Oh,
wait, Magenta,
let me
can you
see.
repeat that?
Yeah, I can.
Like,
I think I can repeat.
like in C, like you can do this, right? Or this, I don't know. But this is already starting with this number. Like in C you can do this, but we're not gonna allow like declaring a variable like this, right?
Yeah,
Without any binding.
yeah, that doesn't.
Yeah,
I don't
because
think
in
that
this
even is
case,
possible in expression-based stuff.
in expression based
I
stuff.
never seen it before, so maybe Nata has a point.
In expression based stuff, what do you mean, man?
In expression-based language, like the ones we use, right?
Yeah, like you never seen in F sharp or in Haskell, you just declare stuff without an initial
No,
value. As far as I
if you
can see.
get the signature files outside, I think it's fine. But they're not being evaluated, right? They're
Yeah.
just
Anyway, I
Because
think
that's kind
Nata's
of a
right.
lie, right? It kind of has a value in any way, like even if you are not declaring, like initializing with something, it has a value, right?
Even in C, that it has a
Yeah,
value, right?
but yeah, we
yeah,
don't want
it's
this.
trash. It's trash, but there is a value.
Okay, so the procedure is to grab the variable from the environment and type check the value from that, right?
uh, no,
Are
no,
you sure?
that's yeah, I'm sure. Because see, you don't have values yet. It's an environment that goes from a string to a type. And the way that you know how it was declared is parameters. Parameters is the only like place where we have type annotations in like so far.
Boom. How are we noting a variable? I don't remember.
Yeah, go to spoon. I think there we're gonna go
Ah,
to
it's
Uh,
spoon.
just variable name.
Yeah, but Nathan, I think that we are talking about the different stuff because
you
what?
mean how to type check a variable, right? It's literally you have a map from a string to types, and you just get what is in this map.
No,
If
but
it
we
there
no,
is
but that
not,
no, but that's the thing. The map that we have is not from a variable to a type. I think it's
no,
from a
no.
variable to a value.
Yes, we need two environments, one for types, other for values. They are different ones.
Hmm. Oh, okay.
So
So
this
this is the type then.
error. Oh
Yeah.
wait,
Oh,
is
okay.
this okay?
By the way, Lemos, I think would be really great, like for the stream and for you, for we to take a look on the stuff that we are doing, like on Wikipedia page and stuff.
Do we
Because
have that?
of course,
Type
and
checking.
no, just like look for simple type the lambda calculus, because then we can even compare what they are saying with the code we have, right? That's how we know that oh, it's not an algorithm or something like that.
Well, kind of the point it is to implement Nathan's algorithm, but well.
No, that's not.
Oh no. Well, we can check that later. But anyway, uh, so that's the thing. Not can you because if we have an environment and we have a name, this it will return the type, right?
Mm-hmm.
Yeah. So this is not a variable. This is already the type, and I can't write for some reason again, but that's fine.
Yeah,
Um,
it's type.
uh,
Let me see the signature.
Oh, it's type
Oh,
here.
it's
Oh, I
literally
can't
just
write.
error.
you can.
Instead of OK here, it is
No,
type.
yeah, I know. I'm just checking the error, the cases for this crap. What is that? So we just return it.
Yeah, exactly. It's the same thing that we are doing with type check for the literal, basically.
Okay,
Okay, so can you do
and
the trick to get me right access, Maggot?
the trick.
Yeah, like read only and then read write. Nice. Did
By the
it
way, like
from.
totally unrelated. Do you have any suggestion regarding how do you say that? Like some flavor of pizza. I don't think flavor is the best word, but like type of
Portuguese
pizza.
pizza.
What a changing subject.
Yeah, but I need one suggestion. And Magueta, that's my favorite one. But
Pepperoni is
in
also awesome. So
The
okay,
what?
pepperoni,
Oh
okay.
no, my pepperoni is disgusting.
I love it.
No.
I love it every
Never,
single time.
never invite me to have a pizza, man.
If I will ever invite you, I will definitely have some other flavors, so that's fine.
In my house, that's not the rule. It's dictatorship. You eat what I want you to eat.
The fuck?
Okay.
Anyway, so in the meantime,
um,
while he's uh,
So let's think. An application.
can
The
you?
application is,
I already forgot what is an application, man.
dude. What the heck,
What
man?
do you mean?
They have a function, a value, you apply it. What the heck?
This
Yes.
this is the
So
application.
yeah, comment like with the.
Kind of, Lemus, kind of. There is only one detail to remember. You see in the left side
Yeah,
and the right side,
yeah,
both can be like any arbitrary expression.
that's fine.
So this would be a like a valid syntax-wise application.
But this is an application, not an abstraction, right?
The one,
Uh,
yeah, is application.
yeah.
Okay. Okay, so you need to pass the arguments to the environment, I guess. Like bind the names,
Yeah,
like
but
the labels or
here's the
stuff.
thing: we need to get from the abstraction. Like, as here's the thing: this is typing, so we're not evaluating. At this point, we should already assume that it's. Oh man, wait, because it's arbitrary, as Nathan said. So, like, abstraction could be any garbage, but it needs at least to result into something that has parameters. So, uh, how are we going to reflect that on the type checking if it's an arbitrary expression?
We need to type check the arguments then first, right?
Yeah, but what if it still has no arguments?
What do you mean? Can you
For
write an
example,
example
like,
here?
yes, like, for example, it's like this. Okay, so x, and then x is a man. Wait, it's not an application. I was thinking of a built-in function, but what I mean is something that gets evaluated and returns a function, but we are not evaluating here to check the resulting function.
That's really
Do you get
confusing
my
to
point?
me. No.
For
What
example,
about?
you need this. You need this, right? So what is, and this would be like, I don't know, int, and then you just do, I don't know, this.
Yeah.
So this is fine because you already know right off the bat
Wait,
this
wait,
thing.
wait. Before you continue, just to get the names right. So this is this is inside arguments.
Yes.
This is the abstraction.
Yeah, let's type shit.
Uh,
Gonna be this.
Mageta, can you like open the link and then like Lemus can like see our screen on Discord?
No,
That
but
way we
I
get
already
to
opened the
see.
link here in the recording. I have this Wikipedia page open.
Oh, okay, so like it's on the screen, right?
Yeah.
Proofs, man. Who needs
Yeah,
proofs?
but that's the thing. Then we cannot all see the same thing, right?
No, no, no. But I'm. What's the point? We were talking about something else.
The point is exactly this. Like the things that guys are discussing, it's exactly like there.
Oh yeah.
Sure.
Little Miller. Where?
So, okay. A holy man, dark thing. So go up there a little bit before this. Like go on syntax. The first lines of syntax, like up there.
Okay.
Like there. So to define the types, like the
Yeah, whatever.
second line.
Abstraction application.
To define the types, a set of base types B must first be defined. Though these are sometimes called atomic types or type constants.
Yeah, whatever, man. This is.
Yeah, I don't see this how this is related to what we
Okay,
were talking
like
before.
he's talking about the base types. So we have like the ones from literals, right? That's the one we have.
Yeah,
Like int and shit, we already know like right off the bat. And then we have a type for functions, right? You
yeah.
see the arrow there? That's what you are talking about. We need to just like type check the thing, and if it's the type arrow, it's the one that Mageta was saying, like, oh, it's something that has parameters. That's it.
Yeah.
But I think
And
we already
then we
have
can
this, don't we?
proceed. It
Because
depends what
Nope.
you
we
mean, because
defined the type function in type check abstraction.
oh yeah, yeah, then that's it, yeah.
Let me open here just a file because I did that on F star. Uh, it's back here. Projects, I guess. Dream ML interpreter. I started my Dream ML.
and,
Yes.
and if you after that, Lemos, you go to the typing rules section, there you have like well written the thing. For instance, like rule one,
Where's my
it's
start?
for the variable. He just says if hex has type I forgot the type of this, like the Greek letter, but if has type like such in the context, we know that X has type such. Oh, I think it's sigma, right?
Yeah, that's
Yeah.
cool. Here, so I have the type arrow t, which is basically just taking input, output, and just a constructor type.
Yeah, so the inputs are type checked and the outputs are also type checked and the return type
Yeah.
is also there, I believe, right? Not Magita.
Yes.
Yeah.
So that's the thing.
Yeah, so the question now becomes types. Yeah, so can you see here, Magita? Here, like types, we have types. I think this is the parameters and this is the output,
Yes.
if I'm not
What is
mistaken.
types?
Types are the parameters, I guess.
Let me
Definitely
see.
here. Definitely they are the
Okay.
parameters. Then
Mm-hmm.
this is the return type of the body,
Yeah, the final.
which is the final. Yeah, so in your implementation back there, I think you call this output and this input.
Mm-hmm.
And in our
Yeah.
case, we also have if the thing is variadic or not, which is fine. So let's go back to this, I guess. So how do you type check something like an application? So we have the argument, we have the
Mm-hmm.
abstraction, and we have the environment, which is everything in this
Yeah.
case.
So you need to basically send it down the abstraction, which can be not an abstraction up to this point. So you need to type check the expression.
Which you were talking about this, right?
No, the first part.
Oh, this.
Both actually both we need to do that.
Yes, exactly. So we need
So
to
just
pick the
call the
arguments and type
function.
check them.
Yes,
Okay,
and
that's the
the
first.
function, the abstraction.
Okay, so parameters. We're gonna do type check environment. Oops. Arguments, I guess, or something like those, like this. And then after doing that, we're gonna type check every single argument before applying to the abstraction. What's the next step?
Actually, just one thing, like that will not return a parameters, right? That will return an okay, blah blah blah.
Um, oh yeah,
Like
this needs to be a
yeah,
case.
and it will return. It should return a function in this case. So it should return.
Yeah, that makes. Wait, why this
Yeah,
needs to
like we
return a
can
function?
assume. Well, it's this thing that we want, right?
No,
Wait,
he's doing the arguments
I'm doing the
first.
arguments first.
Oh, sorry. Okay.
Okay, so this is gonna be something like okay, and then. But then there's a thing. This can be
I
a
don't
bunch
think
of
we.
arguments, right?
It is a bunch of
Yes.
arguments.
So if it is a bunch of arguments, I think we need to do lists map, right?
Yeah, like we did
Because
up
Yep.
there.
yeah, like we did here. It's exactly
But
this.
but just one thing. I don't think you need to check if it's okay or error because it cannot. There cannot be an error up to this point. Like it gets launched before.
Oh, because before being an application, you need
Yeah,
to be an
we're using
abstraction.
exceptions. Yeah, we're destroying the stack trace.
Okay. Okay, so we can
How it should
assume
be.
that if you get into the application point, it's fine.
How it's intended.
So instead of doing like this, we just do arguments here. Does anybody remember how arguments are structured?
I
No.
think they are just a list of expressions, or at least they should be.
Yeah, I think they should be just a list of label and a type.
Let me check.
No,
Involved
wait, he's talking
environment.
about arguments, not
Yeah,
parameters.
Yes.
yeah, Nathan is right. Nathan is right.
Okay, because there are expressions, so you check which one of them. Okay.
Yeah, exactly. So you're gonna pick the function is grabbing an x like this, and then you call type check
I think we
environment.
should just accept arguments as literals. What do you guys think? That will make it so much easier.
No, that doesn't
No,
work.
but
Why?
that sounds limiting a bunch.
No,
Because,
it is
well, then you
limiting.
don't have high order functions and
Yeah,
you don't
exactly.
you
Yes,
d-
exactly. And what
you
what is the
cannot
problem?
apply on variables, you see?
I do not understand the problem. What is the problem?
We don't want that. That's the problem. I think that's fair. That's fair.
Good one.
Uh,
Okay, so we're gonna have a bunch of types for the arguments themselves, right? What's the next step then? After having a list of
Uh,
those.
well, now you need to do the same for the abstraction, and then
Wait.
you compare each.
Uh,
Like you need to have
argument.
all the yeah argument types.
And then we're gonna have abstraction type, which is basically called type check environment with abstraction, which which will indeed call this, right? We'll call this
Mhm.
function here that I'm highlighting.
Yeah, it will be sort of the same thing actually. Yeah. So you can just call type check abstraction. Yeah. Oh no, you cannot because you need to reduce it to that. So yeah, just type
hmm?
check and it should return that thing.
Yeah, but there's a problem
And
here.
if it doesn't return a function, then it's already wrong.
Exactly, but that's the thing. Because if we get a problem, we are not like throwing. We are not throwing to
Dude, the,
type
the
check.
only no, but dude, the only problem that can happen up to that point is that this good could not be reduced to a function, and that's already a wrong typing.
Oh yeah, I
It's
know,
not
but
it's not the arrow. So that's one check. The rest of them, it's like just prone to arguments matching the thing. The rest is just handled locally already. Like it just explodes the rest.
it would be something like couldn't type check application with arguments this and abstraction this. Then it's gonna be arguments and abstraction. Okay, so let's assume that after type checking the abstraction, we got a function back, which is good. I think we need to verify if these matches these.
Yes.
Okay. So if how does equality with lists work? Is that a thing?
I don't know. I think it's just pattern matching.
Really?
I
Wait, maybe
don't
you
know.
have a list dot equal
It
that you
equals.
Exactly.
pass.
That's
But
what
the
I was
maybe
thinking
is
about.
very weak, like very weak on Erlang.
So
Yes, you
let me check
don't.
for that.
Yeah, you just
You
don't.
don't.
We don't
You
have
need to do
equal.
the. I think you need to do the rabbit.
Yeah, the rabbit. This
Ah,
operator, man. It's the best
But
name.
I think if you do a pattern matching where like all the variables have the same name, they should be the same.
Wait, what?
See what I mean? Like for example,
But we tested that yesterday.
function. I don't remember we doing
We,
that.
di- we did. We did test that theory about, oh, if the names are the same, it's gonna type check regardless. And it didn't work at all.
We did that on
Yeah, yeah.
LFA, not on Erlang.
Okay, let's try then.
Let's run the REPL, man. Let's see.
Yeah, open there.
So the idea here is to make. Oh, it's a list, right?
Yeah.
Oh, okay. Maybe that's our. I keep doing ML lists, man. I'm brainwashed. 1, 2, 3, 4, 5. Oops. True.
True. Okay, so you can compare
Well, what
them
if
with
I
the
add
rabbit
6?
operator.
False. Yes, the rabbit is the.
Can you
It's like
guys
equal.
try? Can you guys try with like tuples with things inside and such?
Yeah, I think you can.
Yeah, that should work just fine.
No, no, like, I, oh yeah. What I was
False.
expecting is like a list with a list, and both have like tuples inside.
I have a question.
Like
If we
this.
have the same types, like the arguments types, it matches the types of the abstraction parameters.
Mm-hmm.
If that happens, are we good? Or there is
Yeah,
something wrong
just
there?
return the return type.
It checks, man. It checks all just fine. Just stop worrying and just use the rabbit.
Yeah.
Yeah, the
You
rabbit.
heard it here first, folks. The rabbit operator. The rabbit.
Yeah, but the rabbit is a very dangerous thing for us there because even if it works for the cases we have like right now, and of course we don't know that for completely sure, he wouldn't work if we had like something more on our like type system.
You're thinking too much and typing too little, Nathan. Don't
Oh,
think.
yeah,
Just
I'm not typing at all.
don't think, man. As yesterday, we weren't thinking. Wait, it wasn't yesterday, right? Friday. We weren't thinking, and we could basically finish the base thing for the parser.
That's I don't know
I tell you,
if
man.
I
Okay, let's say that's a good thing.
I tell you, man. Like you don't need to think. Stop thinking.
Okay.
I think he needs to be a list here. I
Oh,
think.
so it also needs to be a list here. Okay. Okay. So let me recap just for a second, just to see if I'm not getting things wrong. This does not require pattern matching because we know that in order to be an application, you need to be an abstraction first. And if you are an abstraction first and you didn't have the exception, that means that that you are okay, right? Is that a thing?
I don't know. Not
Yeah,
looking.
actually, the wrap doesn't work even there, Magita, because of like variadic stuff.
Oh yeah.
Wait, what do you
Oh,
mean?
that's we have on variadic type checking. The rabbit doesn't evolve. Eh, yeah, because it will be different length. Yeah, that's right. Oh, that's garbage.
Oh, so you need to check
Well,
first if it is variadic or not.
if it is not, then we don't. Then we can check like this. But if it's variadic, we can't.
Yeah,
We
so
need
let's
to
make
do
a
a.
first if here. If
Dude.
No, why don't you match
Dude,
it?
just match here, man. What the heck?
well, it can be like that if you guys want. So it's gonna be true
I
here.
think you are getting contaminated, Lemos, with
Yeah,
lists and
man.
stuff.
I don't remember anymore. It's true like this? Yeah, it is because of
Yes.
this.
But I don't think it's true. I think it was a tag, like an atom.
Oh, that's true.
Like
That's
if
true.
is
Yeah,
variadic, I think. I don't
I
remember.
don't remember.
Check on
Let's
the
check
spoon file.
spoon.
Let me just see why this is breaking here.
Yeah,
Syntax
it
error
is like
before
that. It
dots.
is like that. So not variadic, I guess.
Oh, we are grugs.
Oh yeah, that end
Okay.
was definitely missing. So how do you type check if it is variadic then?
Well, you basically needs to because here's the thing, you just need to make sure that every element in the list of the things that will go to the variadic garbage have the same type as the variadic label. So the last thing on the variadic,
Wait. Can
uh,
you repeat that?
for example, let's do an example here in Lisp. In Spoon, the future language.
Not spoon,
So
silverware.
Silverware, sorry. So ABC, right? Let's just do add, okay?
Yeah.
So you're gonna pick, I don't know, A for some reason, and then B, and then I don't know, we're gonna follow this, I guess, whatever. So like you just pick a B, let's say, and then you can pick anything, right? You can pass like two things only. If no, it's redundant. I don't care. Just ignore it. And then we do the thing here, right?
Yeah.
But the point is like this takes an integer, so int. This takes another integer, and this takes an integer. And when we call it, oh man,
Wait, I think the C is actually a list of integers, right?
yeah, no, the C is an integer, just as the label, because every element in the C will be a list of integers. But yes, it's a list.
Oh, so this is a
I'm just
list.
saying that you should. No, dude. I'm just saying that you shouldn't specify this as a list. You should specify as a value,
Why?
or should you not?
No, that's right. No, it matters a lot. Because if you put a list of ints there, you need your arguments to be that. And inside the body would be a
Yeah,
list of
you're
lists.
referencing the argument. That's right. So that would be like a list of lists, right? If I do like this.
No, I'm not understanding. Oh, so you're gonna assume internally that the variadic part
Yes,
is
it's
always a
just
list.
it's the internal assumption.
Oh,
Yes.
that's fine.
Yeah, it's always a list anyway.
Yeah, it's always a list. Yeah, so
So
go on.
and then in the call of this garbage, we're gonna call add 1, 2, 3, 4, 5, 6. So like this portion here, I'll just separate this portion here. It's the one that actually gets checked over by the same type of C. So that would be just like, okay, this is an integer, this is an integer, this is an integer, this is an integer. So all of them need to be an integer. But here's we go back to what we were talking last session, I think. Because it would be easier just type checking if this is a list. Like we just okay, this is now a list of that crap. So is
Oh, that's
you
why
see, you
Nathan
just
wants to
like
make the internal implementation or the language's implementation of the list.
well, that's one reason because you just check okay, is this a list of that type? Like that's it.
That's it. Yeah, that should be a
So we
lot
can do
easier,
that.
indeed.
I mean, I don't know about a lot easier. It's just like a hassle. It's just an exception we are adding here. If we do it, we can do it. That would be just like checking, like a for all. Do we have for all
Let me check.
lists? All. So we check a predicate on the list. Okay. So we just check if everything has the same garbage,
That
and if
that
they do,
that
that's
works.
fine.
That works.
Oh, yeah, that's a nice function.
So no.
Okay. So how would that go? So you need to pick the last of these, right?
Yes, the last one
Okay.
of that.
Do you have a last function? Yeah. Holy man. Today, for the first time ever, we have functions that we actually want to use.
And then we discovered the last actually returns a sequence of.
Types.
If you didn't have last, I would start screaming.
No, but you could reverse and do head, man.
Yeah, but it is very weird to have last. Oh. Because usually you don't use
No,
that
but
with
probably the
lists.
internal implementation it is a reverse and a head, Nathan.
Yeah, probably.
Uh, I don't think so.
I mean, who cares, man? It's Erlang.
No, that's not what I'm talking about. I'm saying that usually we don't have like last functions
Oh,
using like lists.
why not?
Yeah, why not?
Well, because usually you don't care about the last because they are linked lists. That's really bad to be using the
Well,
last.
it
No,
is pretty
it is
bad, but
bad.
that's not a reason not to have
Nobody's
it.
saying it's not.
Well, let me take a look like which language has that.
Nobody's saying, "Oh, it's really good." No, it's not, man.
You don't need the dot there.
Uh,
Here. You don't need this dot.
Wait, I'm confused now. Oh no, wait. This is not.
Comma.
No, no, wait. This is the last. This is the variadic types list. I don't know. Then the
Yeah.
list goes here. Variadic types list. Then we're gonna go through. We need the first one. Yeah, we need the first one also. Like in the add, we need the A or the B. Let's pick the. Let's pick this one. So lists.
So the things before the last one.
Exactly. So types. Then you're gonna verify if it is equal to this.
Uh,
I guess.
wait. The type of.
So let me
But
explain.
how do you? Uh,
Yeah. So
I
my
look at
idea
the head.
was my idea was something like add 1, 2, 3, 4, 5, 6.
Hmm.
So 3 to 6 is variadic types list. So the types of this.
Yes.
This is gonna be the type of the one.
Yes.
And then we are doing lists all with the variadic types list. There is the 3 to 6, and verify if each one of those has the same type as the one.
But you don't need to check the one.
No, I'm not checking the
No,
one.
man.
I'm
No,
verifying
no,
if
wait.
3 has the same type as 1, 4.
No, man. No, wait. That's wrong. Like you should check by the reference on the signature of add. Like add. Let's
Ooh.
do add again. So add is like int. Let's
No,
just
add is
do.
this, man.
No, wait, man. Ignore that. I don't want to think.
That's the new Magetta policy, man. He doesn't want you to think
So
anymore.
here. So that is the type. Imagine. Let's do the normal Lisp thingy. So this, right?
Yeah.
So the one you should match with this, the two you should match with this, and the rest you match with this.
Yeah, but we don't have this
What you're
information
doing
here.
is that you're matching three. You do.
No, we don't. Look at this. This is the add type. It is a function
Yes.
which has the variadic information or not. It has the
Yes.
types of the parameters, which include all of those, and also has the
Yes.
type of the body, so the return type. So it would be like something like
Sorry.
this.
Oh, moment. Let's wait before the other types. Okay, this.
Yeah. So this is the return type is this one. The types are all of those. The variadic
Yes.
information is just to see if it's variadic or not, and this is just to get the function tag.
Yeah, but why are you checking if 3, 4, 5, 6 are equals to 1 in
because
terms of types?
because we don't have enough granularity here to say that, oh, uh wait
What that would fail.
wait a second. Oh no, you're right, I'm making a confusion. 3 to 6, they are in here, right?
Yeah, they are the arguments. That's
Yeah, they
true.
are the arguments. So this, yeah, so I was totally wrong. So this is the last
Yeah,
type.
because here you're not gonna have this on the type annotation, right? You're just gonna have int there.
Exactly.
What's telling you that this is that the last shit is actually the thing is the variadic flag.
Exactly. No, yeah, you're totally right. So let's see how you get. Yeah, so the arguments, they also need to have the type information as well as the labels. We need to remember that at some point, but that's fine.
Wait, what? The labels?
Yeah, because I just said before that when we are doing type check abstraction, we made a convention that the labels will not only contain the names but also the types. We also don't
Yeah,
have to have that to the arguments now.
no, we don't.
No, because the
No, now I'm
arguments they get
confused.
evaluated,
The
not evaluated.
arguments?
The arguments you just propagate down, and and the resulting expression has a type because they can be an arbitrary expression as well.
Wait.
Like the argument, think about this. The argument needs to be evaluated. It could be an arbitrary expression, so we don't know the type yet. So you type check that thing. So you call type check on the argument,
Mm-hmm.
a specific argument. The resulting type of that thing, we match with the type of the signature of the abstraction.
Mm, wait. Can you repeat that?
Okay. So the argument, look here.
Oh,
This
okay.
could be, let's speak it like this. Okay. Let's go parentheses how. Uh,
Parentheses.
F, and then we pick. I don't know how to make that signature, so let's just do this. Int. So the result of this, we know it's true, right?
Yeah.
But what it's gonna do is that it's gonna basically take a function int to int. Oh, sorry, I'm stupid. It's gonna pick just int. Never mind me.
Okay.
Anyway, so it's gonna pick int, just an integer. So we don't know the type of this yet.
Yes. But this is the
So what
argument,
we
right?
need to do? Yes, but here's the thing: we know this already, but this itself is the argument. So what we need to do is
Type
call
check
it
this.
again, type check this, and then what's it's gonna do next time? It's gonna separate this into the abstraction. This is the argument,
Yeah.
and then now if this is already type checked because this is the bottom, this is
Yes.
literal. So this already returns the type for us. So we don't need to add a convention on the arguments. We can't even do
Oh,
that.
okay, makes sense. No, makes sense. Makes sense. Yeah. So we are because we are doing this here, right? So we're grabbing all the arguments and type checking them one by one, and we have
Yeah.
a list of them. And then what we are doing here, we are verifying if all of the types inside that list of type checked arguments, if they
Mhm.
correspond to the rest type of the variadic part
Yes.
of the function.
Yes.
What is this if?
No, the
I
zif is
don't
because I
know.
copy pasted from here. Just ignore it.
So here's the thing: we just need to separate again the variadic part, which is the last, right?
Yes.
And then from the arguments, and then we just like go consuming the list until we get to the last argument of the first one. When we are finished, here's my algorithm. So let's do two examples here. I think it's easier. So so let's pick two things here, okay? So we're gonna have int, 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 and this is the variadic part, all right? So what we're doing is that we want to do um, int, 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 int. So I'm just representing the types, okay?
Yeah.
And then you go, okay, so this matches with this, fine. This matches with that, fine. But okay, but this matches to this, but there are more. And this is variadic, and this is the last one. So I just assume that I just check now if this now represents has all the same types as this. If it does, then it's fine.
Yeah, so I think I know how to do that. So that here's my pitch. We're gonna do the same thing that we were doing here, but we're gonna exclude from here the last one.
Yes,
And then if
like
this
that we can
works,
do.
then we check the last one using this.
But
By
one
the way,
thing,
Mageta,
we
the way you
have many
described,
arguments.
I think would be the
Sorry,
most performant way to implement, man.
the way
The way you
described.
described it probably is the most. Yeah, I think I agree with that. The most performant way of doing it. Anyway, so um, here's my idea. I don't know if that makes sense, but let's see. We need to do what the beginning of Mageta's description of checking the non-variadic ones first. I think we just need to do this if
Mhm.
again, but we need to exclude from here the last one
Yeah,
because the
but
last one is
here's
the
the thing:
variadic
how
one.
do you know? How do you know how many arguments are there?
We
You
don't need
just
to
need
know
to
how many, I think.
you just need to pick the quantity that you have before the last one, right? So for
Yeah,
example, you
so it's
do
this
like
minus 1.
length of types. Yes, length of types minus one, and that's the portion. So just I think there's a list slice. Let's see.
No, 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 but I don't think we need to do in terms of length. I think with
There's
the
a
I think
split.
that the rabbit operator will check the length and the types, like, because in your description you were consuming them. Here we are doing the consuming part, but using the rabbit operator. We are checking
I
int
don't
with
think so,
int.
man.
Let me try to explain. Yeah, yeah, that should work fine. Rabbit int int int.
Like this, it's fine.
Yeah, so
But the
what you're
problem
gonna
is
do.
we're gonna have this and what not.
Wait, no, wait. But that's my idea. So instead of having the ones before the rabbit operator are the parameters of the function, right?
The ones before, yes, they are.
Yes. And these are the ones from the right ones are the ones from the arguments, right?
Yes.
Okay, so what my idea was, what if, oh, but we don't know how many are from the variadic part, right?
Yeah.
That's the
So
problem you're
that's why I
talking about.
said like
Yeah.
you go by each one of them and then you just exclude this one and then if we slice we can do the rabbit, right?
Yeah, no, that makes sense now because you don't know how many are in the variadic part.
Hmm.
Uh, oh man, that sucks.
Oh, we can split the function the thing here.
Yeah, let's do that. So how does this split work?
I don't know. I'm just guessing.
Here. Okay, so splits list 1 into list 2 and list 3. List 2 contains the first n elements and list 3 the remaining ones. So yeah, it's a normal thingy, apparently. I think it returns a tuple, by the way. Yeah.
A tuple like
Yeah.
this.
Hey
Yes.
guys, just something for I don't forget to tell you later. But I just remember we need a special case on some stuff because of Lisp has the thing regarding like no arguments instead of receiving like unit. We need to account for the cases of like both are like
Oh,
empty
true.
lists, and on the
Yeah.
parsing we need to also consider the like parentheses with a inside to be application to no arguments, right?
Yeah. But that's like parser level, right? We don't need to do it
No,
here.
no, also there because you need the how can I say that? You need to pay attention on that part there also because the parser will return like an application where the parameter should be like none and the argument is
Yes.
also none.
Hmm. But
Can you write down these observations? Not.
Uh-huh.
I think we
yeah,
are
but we
missing a
don't need
list.
to do anything here, right? I don't see anything.
Uh, I'm not sure. Depends if maybe you're
There,
already handling like by
we just
chance.
need to to account for. But in the case of Lisp, right, we should have one parameter, which is unit, right?
Uh, no, in
Like in
Lisp,
an
no.
application, like an empty application. No, man, I'm saying that's something we can do in the parser just fine.
I'm not even sure what you guys mean by empty
That's
application. What
weird.
that
Like
means.
this, like a unit, a function like the fun x that picks nothing, and then just do
Oh, okay.
uh,
So the empty application is basically in Lisp
nothing.
adding parentheses.
Yes, like
Okay.
this.
Yeah.
Actually, I thought we were doing this, right? For this case. So this, and then like for calling it, you just do what the fuck, man? This, and then it's just X, right?
Yeah.
So you can call it. But then on the parser, we can. This is only valid if this is a function, right?
Yes.
So so we can avoid doing this, like unit, whatever.
Yeah.
So we can just insert like when we are parsing this, we mount the tree with a parameter like in the application that is unit.
Why not just the empty list on parameters?
Why
Because I
not
think we're
just
gonna
an
have the
empty
unit
list and
type.
parameters?
We
Well,
don't need
here.
the unit type if you have this possibility in Lisp.
No, but now we need to
I
discuss
I don't see the problem,
the
man.
advantage of using an empty list in this case. I kind of like having the unit type, but
We can
Wait,
have
what do you
both, but it's not like excluding the unit type. What not I'm saying,
no, yeah.
but
But I'm just thinking we need the unit type anyway for return, right?
yes.
yes.
Yeah, then it's okay, but then the user can choose, right? If he Oh. Yeah, we only need a syntax for the unit type because it cannot be like parentheses anymore, right? Or at least oh, maybe it can, but yeah, I agree. If we need for the return type, we should add anyway.
Yeah, but I also agree with Namageta that this observation I don't think will affect the implementation of type check application for now.
No, no, but yeah, but this that Magenta said, if we include the unit type, then it doesn't work properly because then passing no parameters and pass unit type would be the same if we have the unit type in the language.
That's if we do have passing no parameters and passing unit type is gonna be the same.
Yeah, you could exclude the passing no parameters also, and then you will
I
have
like that
one of
approach
the.
of excluding the pass no parameters.
Yeah, then you have like only unit as in other language.
Yeah, I think that's fine.
We argued so much to reach the same conclusion.
No, but now I
Anyway.
understand it better. That's the
Oh,
point.
isn't that the intention of arguing?
Yeah, exactly.
Oh yeah.
Okay, so going back to here, we are splitting the lists of in the example ints, and then we are grabbing the ones that are hard coded, right? They're not variadic at all, which is gonna be this one.
And just a thing, what I meant is not necessarily the intention of arguing. But anyway, go on.
So these are we need to check list two with
Which
with
is which, by the way? Let me see on this split.
oh, it's list two, this one. Okay, and
So it
then
splits. Okay, list one and two. I think it's in place. Yeah. Okay, it shouldn't be otherwise.
oh, I
Okay,
still
so we can
have
check.
nice in the copy paste.
But we also need to split the types.
What do you mean
We need
split
to
types?
slice the types. Yeah, because the types need to be
Minus
without the
one.
last one.
Oh,
Yeah.
do you have
We
tail?
can. Well, we have, but we can reverse and get the tail and then reverse back.
Do we have tail for real Z's? Like,
Oh, well, yes,
I don't
which
think
is
so.
pattern
I don't think
matching.
so.
We do pattern matching.
Oh, well, well that works, but that sucks.
But like we need to flip, right? This is not doing anything.
Yeah, maybe we're gonna have to flip.
So
Oh man. Okay.
come up with something, Lemus. I'll be watching here.
Uh, no, I don't think so. I don't think we have a choice in this case.
Oh, we can split, man.
Man, by the way, this is wrong. This should be.
Oh yeah,
Oops.
that's the
Should be
outside.
here.
And then here we do the if.
Yeah, exactly.
So let's do the. Oh, what the heck, man?
Okay, so without better matching, what's your plan to get the tail?
So my plan is no var part,
Yeah, in var part.
var args. Let's do this. No var args,
Type
var
args.
args. Okay, and then in this part,
In this part, we want to get the tail of types, which is the
no
parameters one.
var, no var. What's the name of that thing? Let's type the type. Sig, which is from
Yeah,
signature,
signature.
and var type sig, and
How are we
then we
gonna do
just
this?
split.
Nice.
telling you, man. Like, why are you thinking? Like, just do it. Stop thinking.
No var amount.
Can be at types. Doesn't matter. I don't think it is on length. Oh, what the heck? What the heck?
Here.
Here. Uh, what? Oh, comma. Yeah, shitty language. Uh, and then here we do. This is on the arguments. This is on the types. Why are we doing this, man? We could just exclude.
We don't have tail, man.
We have take while.
Do we?
I think we do.
No, we do have take while, but how is the signature of that? Predicate and list.
Predicate and list.
We also have
Who
nth
cares, man?
tail. We have also have
Yeah,
nth tail.
yeah, who cares? That's right. That
Okay,
works.
that works.
All right. So gotta be pragmatic. All right. So
Okay. Okay, so
so
the
what is
if
types?
is non var type sig, I guess, and non var type args with the rabbit. Yeah. No, not sig here. Args. Okay, so if the
And
non-variadic part of the signature is type checking with the non-variadic types of the arguments, now we need to do the same type checking, but for the variadic part, which
yes,
is going to be this is equal to this, I guess. Right?
yes.
Okay, so it's
So
going to
remember
be,
that this, the variadic type sig, is just one type. It should
yeah,
be one. Like
yeah, no,
there
that's fine,
shouldn't
that's
be
fine.
too many.
So let's do the following. If enter, then exclude all of that, and then instead of argument types here, it's going to be var types args, and if all of them are equal to var type sig, like this. And then if this is true, we just return the return type finally. But if this is not true at all,
Then it's like
then
this.
error. So then
And then
this
if it
true.
is not true, then if it is not true, then this is so trash.
It's fine.
No, man, it's not.
It's fine. It's
Very
really fine.
trash.
What's gonna be the error of this one? Uh, variadic, variadic argument type. No, type of the variadic argument does not match variadic type of the signature in abstraction. Yeah, so it's gonna be arguments and abstraction.
Dude, why can't we evolve this? You're
Okay.
not gonna make me case match a list all, right? Please. Prove it.
Oh no. I don't think that was the problem. What is the complaint? What is it complaining about?
It's complaining that oh man, this there.
Oh, okay. So no, we can go back to the if then. The if is rather better than this.
Oh, I don't know. The else is a true, so I'm not sure about that. The false condition is a true. Oh, I don't know.
Oh no.
You gotta remember that it's true, that it's false. Like,
Oh no. Okay. Is it
and I
complaining now?
think now, yeah, I think we now need parentheses here. No, what the
What
heck?
is it why is it complaining?
Illegal
Valid
guard
guard
expression.
expression. Guard. What do you mean? Guard expression.
Oh, are you telling me? Oh man, no! Please don't tell me we cannot do, dude. I mean, let's just use a case, man. Who cares?
The
I- I'm not
Pharmatic Magenta
battling.
for you guys, just for
I'm not
lols.
battling. I'm not battling this bullshit. Not today. That's even more readable, man.
Oh, that's debatable for sure. I think there's something wrong still.
We're doing parentheses.
Oh, nice. Okay, is this type
Well,
checking
not really,
application?
but I guess if we didn't, probably we messed up with some pattern matching up there. But let's try.
No, wait, but we
So
don't have an example. I think we should make an example. Is Nathan still there?
yes, I don't know. Probably
I'm
he went to
muting.
grab his
Oh,
pizza.
okay. Okay, that's no problem. We need to
I'll
make an
just go
example now.
to. Yeah, so I'll give you guys this task. I'll go to the bathroom. I'll be back.
Okay. Uh, I have a question for. Oh, Nathan is eating. Okay. So later I will ask.
You can ask.
I just want to know, just to see if I'm understanding things correctly. The only, how can I say? The only function that will ever call type check abstraction will be the type check application, right?
Type check abstraction. The only one we've ever called that.
Yeah, aside from this redirection here.
No, no. They are not related at all in this
Oh,
sense.
so then this may be a problem.
I don't think so.
Yeah, I think so because the type check abstraction returns this, right?
Hmm? Returns what?
Returns this
Wait,
function variable.
I cannot see you.
Oh,
Oh, okay, I'm seeing Mageta's screen. Wait, just a second. Following lemons.
yeah. So
Okay.
this is the return type of the type check abstraction.
Uh-huh. That's not a problem.
No, wait, but the only other function ever type checking this and doing stuff about it is the type check application. All the other ones are doing nothing about that.
Yeah, not quite, Lemons. You are saying that is the only one that care about the format of this. You are right, but it's not the only one that you check this. If you have the expression it is abstraction. You type check that. Doesn't matter if it's an only expression, if it's an argument, if it's whatever. If it's inside a list,
Oh.
type check abstraction can be called like anywhere. The only thing that we assert, if it is of some type, that's the application, at least for now.
Yeah, so about in the meantime that Magetta is went to the bathroom, how about implementing this, man? Do you still think that we need the list implementation like internally of the language, or can we
Oh,
use the
yeah,
Erlang
like,
one?
uh, yeah. The
Because
thing I was saying, Lemus, is not regarding how to type check. It's because the user of the language, it receives as a list. So how can he treat it if there is no list in the language?
oh, that's interesting. So the user itself defining a variadic function cannot use the variadic part, like variadic argument of his own function because we don't have lists for him.
Yup.
Oh, I see. Yeah. Yeah, but
And then you can.
I'm back,
yeah, but
losers.
for the purpose of testing, I don't think this is necessary then.
I agree.
Oh, okay. Nice.
Where? What are you guys doing?
I no, I was just asking at a few details to see if I'm understanding this. Okay, so now let's make an example. So, uh,
Should we do that on test? Oh
yeah.
wait, it's failing here.
What is failing?
Least illegal guard and expression. I think you cannot do this in an if.
Mm,
Like you can't
wait,
evolve shit in an
Lemos.
if.
Go
By
back.
the way,
Uh,
we cannot do examples for variadic, I guess.
no, we can't because you're gonna skip. You're gonna already
Okay.
make. How can I say?
Mm?
You're gonna already make the AST and just call type check with the already
Mm,
built. Like we are skipping that problem that we just talked about.
wait.
We're gonna use Mageta's idea of having a single type for the variadic part, and
No,
then we're
no,
gonna
I'm.
assume it's a list internally and stuff like that.
Wait. I have to
Wait.
get a call. Just a sec.
A single type?
Yeah, yeah, it's
What are you talking about?
yeah, because it's exactly what you said. So imagine that you have an add. You're gonna have
Uh-huh.
an int, and a third int. The first two
Uh-huh.
ints they are non-variadic and they are must-haves, but the third one
Yes.
is the type of the elements in an implicit list,
Yes.
and
Which
which we're gonna apply to the arguments of in the variadic part.
yes.
Yeah, so
But
that's
that's
no
not
problem.
optional, right?
That's
That's not optional.
what
Like
is not optional. What do you
you
mean?
cannot leave it empty. Like you need to add 3 at least in that case.
But that's wrong then, right?
Why?
Because
No.
you should be able to do an add 1 2.
No, wait. That is the rest. There is another thing called optional.
Wait, I'm confused. Can you type down that?
Like, is the rest. We didn't make the thing in our evaluation as rest being optional.
Oh yeah, no, you passed the arguments already in a list, right? I remember that.
Yeah.
We kind of treat it as well. The syntax does not portray these variadic versus non-variadic because in order to pass any sort of arguments, you always need to put them inside a list, right? Hello?
I. I'm thinking.
Okay. I think we even did a test about that, so let's go to test.
I don't remember. But
I
anyway.
I'm back.
Let me check.
Lemos, but the thing is, you can, but you just cannot use the variadic inside the body because you don't have the.
Oh, here. Just a second, Nathan.
Mhm.
Can you go where I am, Mageta?
Yes, sir.
Yeah, so here for instance. We are putting non-variadic here. All, but that doesn't matter because all the arguments are already inside a list. In the ST level, the variadic
Yeah.
information is not being portrayed here because everything is already inside the list. If it
I
is
don't get the
variadic,
point.
no, wait. We were discussing before about being optional or not being optional, right?
Yeah.
So, as you can see here in this test, this is not variadic. But the way that we pass the arguments is inside a list.
Yes.
And
Okay.
this is variadic, and this is also being inside a list, the
Yes.
arguments. So what I mean with that is that the if the function is variadic or not, it doesn't change the way that we pass the arguments to it. So it doesn't
Yes,
matter if
but
it's
on the
optional or not.
evaluation, what you're gonna match with?
On the
Like,
evaluation.
check here on the typing and not evaluation.
Oh,
Can you go here
where are you? Wait.
and here?
Oh, here.
I'm back on the application.
Yeah, here.
Yeah. So look here. This. Oh wait. On the variadic part, this would fail or not because we have a thing on the var on the signature, but we don't have on the types. So what happens in this case? Because this list is empty, so this thing will do nothing. Let's
Wait.
check. Let's check what Erlang does.
Oh, that's interesting. I think I got it. What happens if the thing is empty?
Let me see what Erlang does. This beautiful language. I mean, this language is beautiful. You gotta agree with that.
Man,
What about
again,
Finland?
if I cared, I would make a montage right now, and it's good.
So this is false, okay? This is true. What about an empty list? An empty list is true. Okay. We can pass
It
an empty list.
works.
Okay. All right.
So it works.
So if you know that if they ever change this implementation to, I don't know, an empty list now represents false, then we are screwed, right? Because we're not never gonna catch this bug.
That's true.
We, we can add a comment here.
Yeah, that's that.
Uh, so uh, lists all on an empty list, meaning that the variadic part is empty, i.e., hence optional, hence optional, needs to yield true. Otherwise, this logic is wrong. That.
Um. Okay, so we also let's now try to formulate an example just for testing purposes. Something that I want to do, because I remember this from the last time we did testing, is that the name of the file that is related to testing a module, they need to be the same. What about
Oh,
changing?
that's garbage.
What about changing the name of spoon to, I don't know, compiler or evaluator or something like that? Then we can have two file tests for the type checking and for the evaluation process. What do you guys think?
Yeah,
Okay, so rename
but but you're gonna rename now, man. It's probably gonna crash everything. Oh, it's crashing anyway, right?
evaluator. Let's see what.
Evaluator.
Yeah. Okay. So now that we have this, we also need to change the name of this to evaluator. Okay. Okay, that works. Um, those changes were those changes applied to you? Yeah. Okay. So now let's copy paste the evaluator test and create the typer test. So typer test. Nice. So let's copy this. Oh no. Can I do this? Oh, nice. Here. This is gonna be the typer. Okay. Okay, Mageto. Now let's go to the typer test and try to formulate a test for this.
Alright.
So the easiest one ever, as far as I can tell,
Is an integer.
is the literal integer. Yeah, let's try that.
Yeah. Let's delete all of this, man. Most of it, actually. Let's just keep one here.
Okay, that works.
Wait, where are you?
No, I was changing because you need to actually do
Oh,
like the module column and then the function. I was changing the spoon to evaluator here in the other file. Nice. And then we have the prelude. Then I'm gonna have type checking here. Nice. Okay, so the first one, we actually can remove this also for now. So this is gonna be type check test. The first one is gonna be typer type check.
I really. What? I typed that.
Really?
Dude, is our thing. I think our things are auto sync. because I had typed like typer type check already.
Oh, that's not good. Okay,
Try
so
logging in again.
yeah, no problem. But I hope nothing gets destroyed along the way.
Well,
We're gonna discover that pretty soon
we will.
in a very very sad way. Here, here. Okay, joining collaboration session.
Oh, maybe need to accept it. Okay, so let's see here. Type check, and then the two things that we receive is the environment, which I don't care, and the
No,
literal.
let's put the prelude there.
Okay, so we need to import it.
I don't remember how to do that also.
Let me see.
Can I type?
What were
I
we
can't
doing
type again.
before?
Do the trick.
Oh no, that's Trish. Why does this kind of thing only happen with you, man?
Do I need to answer you? I think you know the answer right away.
Luck. Good luck, right?
Lack
That's
of
the
luck.
lack
Completely,
of thereof.
yeah,
Lack thereof.
completely lack.
Okay. Literal. Okay, this is stupid, man. Like this, if it doesn't match with them, I don't know what we're doing. Because this
Yeah,
is literally just
yeah. This
a.
doesn't need the prelude, but I just want to make the standard. Like everybody has the prelude as a base. Let's go to the evaluator for a second. Yeah, so it's gonna be this and
But we need to infer from where it is from. Right? I don't think we need to do that.
oh really? Interesting.
Yeah, we just. I think we just need the. Where is the prelude? It's on the prelude module, I guess. So this. Yeah, it works.
Okay.
So let's compile. Oh, fresh. Rebar tree compile. Okay, is unused, but it compiles. Uh, rebar
Oh wait, but
unit.
that's a good warning because I think we need to add that to our type checking.
Yeah, we do.
Yeah. So how we are doing that?
So it says here that there are 14 tests, which I guess this is the 14th. So
Yes.
I don't know. I think it
That
is right because
sucks,
I
man.
remember having 13.
No, I think we have
Let me see.
13 and it is summing up.
Uh, I don't know.
No, it's totally
Typer
summing up, man.
test? No, man. Wait. Oh, this is a list. All right. Never mind me. So this needs to be asserts inside asserts. That
What is the just a sec. Environment and the variable. Okay.
environment is unused. Typer. Okay. Okay, you're changing the code there.
Yeah. Okay, now it should be used. Let's see.
Okay, 15. That's right.
Nice.
Let me just add another one just for sanity, because I'm not sane. I don't know if you guys noticed. 16. Okay, so this is right.
Okay.
Habemos testing.
Okay, we know how to test stuff, I guess. Let's make
You guys.
some of those a little bit more interesting. So instead of integer 3 times, we can have booleans as well. So boolean true.
Yeah, but we don't need to test them. That's trash.
And that's trash.
Let's see. Because it's literally just a pattern matching. So let's test a condition.
Let's test. Oh, that's interesting. Do we know how to? I think we
Yeah,
didn't implement
we
that.
did last session. We did last
No,
session.
no, we did the condition for evaluation, not type checking.
Type checking a condition. We did that.
Oh, that was the first one that we did. That's true. Oh, we can copy paste from the
So
evaluator test. Nice.
condition should be the first dude should be a literal integer. Oh, let's do a integer, a literal
Okay, so
boolean.
this is the structure that we are using in the evaluator. So condition, then
Yeah,
we
that's
have
what I'm doing.
boolean. This is like this.
And the last one, which is well, the other two ones. So let's just do integer uh, to, 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 uh 1, I don't know, and let's copy this crap.
Wait, but wait.
So the result should be integer.
I believe
Let's
I'm
see.
confused, dude. Wait a second.
Yeah, it's working.
No, no, no. But
So if we change this to, I don't know, boolean, we should fail. Yes, it fails. Cool.
wait. Oh, so this is the predicate, right?
Yeah, this is the condition,
And
this is the
this.
then, and this is the else.
And if you when you added this boolean here, it didn't type check.
That's
That's cool.
so it cannot be like two different two different branches.
Try an int on the condition.
That's cool. That's also a good test.
Yes.
Yeah, but let's try like replicating this instead of changing it on the fly. So
Yeah, but how do we handle errors
we just
in
throw an
this assert?
exception.
No, 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 no. I mean on this assert, like assert error. We have
Oh,
this.
oh, so we have a term and an expression. How does that work?
I don't know.
Uh,
Lemus, time to open the
document
documentation.
documentation. I don't even remember how we discover the assert process to begin
I
with.
don't remember as well. Well, you gotta watch the video to check that.
Oh, I don't. I'm not
Let's
sharing the
run.
screen. Let me share my screen.
Okay, it's failing. Nice. I think it's assert error. Let's see.
Okay. So assert. Assert not as well. Good to know that you have that. Error. Equivalent to assert exception. So you have a term and an expression. What is a term?
Uh, uh, I don't know.
That's cool.
I think it's anything, like any garbage.
But how do you?
Expression.
I think that the expression is the one that we are gonna actually like throw the exception, right?
Look for the exception. Assert expression. It's tests that expression completes. Wait. Completes abnormally with a wait. Okay, with an exception of type class
And with an associated
with the
term.
term associated term. Okay, so you send a term and then it sends that crap. Okay, but the hardcore part is identifying what kind of exception that thing throws.
Do you have any clues about that in the terminal? Does the terminal tells us?
I guess it's just failure error that it's saying here,
Let's
but
try.
I don't know, man.
Let's try. Let's try failure error for now.
Oh, that's trash exception.
That's trash.
So it's this, I guess. The term and the expression.
Yeah, the expression is the. We're probably. Oh, the rabbit operator is wrong. Just remove.
The rabbit.
No, remove the integer as well. Yeah.
Yeah, but what is the last thing now? The expression.
No, this is the expression. This should be the
No,
expression.
but there is a term as well. There are three things.
Three things? Really?
Yes, the class, the term, and the expression. What is the expression, man? Expression. Tests that expression completes abnormally with an exception of type class, blah blah blah. And with an associated term.
What is a term?
No, I think a term is just like a general garbage. Like, yeah,
A piece of
piece of
data
data.
of any data type is called a term.
What the
Okay.
fuck is expression then?
Yes. Let's infer by the others. Go back there to the assert. Check the assert equal. So you see that the second is the expression. So that is the thing that we are. Wait, we were using it differently, weren't we?
I don't remember. Let me check. We are using a search, and then yeah, we're not using a search equal. I guess we're using this like interrogation
Oh,
mark one.
yeah, yeah. We're just calling. It's just one
Oh, here we are using this one.
assert. Is that what they're? Oh yes, yes, that's right.
So this is a Boolean expression. Okay, so expression, I think it's what we are doing, like
It's the
calling.
code. Yeah, it's the code you
It's the
need to
code.
run.
So we need to discover which one? Term then.
A term, I think it's the what it evolves into, which is an exception. So I don't get it. Notice
That's
that both class and term can be guarded patterns, as in a search match. Dude, if only we had an
search
example. Exception
exception Erlang
Erlang.
example.
Got it
Oh, here.
started with years, yeah. Search for exception.
Oh, here. Oh, this is just a commentation. Oh, wait, classes. We have exit, error, or throw.
Uh,
And maybe the term is the failure error that we were guessing before.
oh, our case is an error. Okay, makes sense. Okay, and what is the other thing?
We have to have three things, right? So class, term, and expression. Class is going to be error. Term, I think, is going to be, I don't know, that failure slash error thingy that you were guessing before. And the expression is going to be the expression itself.
I don't know, man.
That's just a guess, though. Exception. Yeah. So these are the ones.
This is
Oh, we
confusing,
have
man. Why
no, no, no.
not?
But we have this. Assert error. This is the one that we want. Assert error. It seems to be a sub function that calls this, but you only have to
And
pass
what
two
does it do?
things. It is
Oh, term
yeah,
and the
probably it
expression.
is calling assert exception, but passing already the class.
What
So
is term then? Dude, what is term? I don't
wait,
I don't understand it.
wait.
Give me the term. What is a term?
Oh, here it is an example.
Stack,
Assert
pop,
error,
stack
bad
name.
arg, and then the expression. Bad
So
arg.
the term
Mm. Is this the type of the
expected.
error? Maybe.
Oh, I see. Oh no. Dude, look at here the terminal. Can you see?
Just a sec. Yeah,
Oh no. The term that it's expecting is the this piece of code here.
but that doesn't make sense.
I know. That's stupid. Dude, let's try copying.
No, 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 no,
Oh
no, no,
man,
no. Let's
that's
put the wild card. Let's put the wild card. Let's just see. It doesn't really matter the term then.
well, the
Assert
term.
assert error put like underscore comma. Oh,
Well,
nice.
yes, it compiles. So it's compiling. Okay, so it's matching if it's only throwing an error. If we do boolean, oh no, boolean, ah, and we run
No, wait, but
this.
that's wrong then. Oh no, this should not, right?
Yes, so it's fine.
Nice. But nothing was raised. Nice.
Okay,
Oh man, this is cool.
let's do it again. The same thing, but this time let's do a true things with one being a string. Mm,
Yeah, that's a good test.
hey. Okay,
Okay.
so far we're doing just fine.
Yeah.
Now let's push a little further.
Yeah.
So let's do an abstraction
Oh yeah.
and a variable, which are easy. So let's try a variable
Oh
first.
man, there's something that I want to do. I don't know if we should do that.
What, Lemos?
Oh man. Okay, I'm gonna do
What
it,
should we know?
and then we can get mad later. I want to follow the same
What are
pattern
you
that we
gonna
did here. No. Here. 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 Wait just a sec. Type check with environment. That's fine. Type check. Type
do?
check. That's fine. And then we're gonna have a function called type check. How we are doing this in here? We are doing like
I'm not
this.
looking at where you are. Let me see.
No, continue doing the testing. That's fine. I'm gonna call this type.
Let me just do one more. So prelude abstraction.
I think that's it. So now we can dump this. Nice.
So an abstraction takes an environment abstraction and the parameters. How are the parameters again? I don't recall.
Just go to the evaluator test and check there. Actually, that's a good thing. I don't think we're testing abstraction in the testing. We are only testing
Oh,
applications.
here. Variadic info and then
Oh
labels.
no, it's here. It's
So
here. We have an example here. Let me copy paste. Okay, so this is how you do abstraction, my dude. But we need to remember that the AST for type checking is slightly different than the AST for evaluating. So at some point you're gonna have extra tuples.
so we're doing just with the thing without any types here.
Yeah,
We need to
in
change
the
that then.
evaluation part we don't have types.
Okay, we need to change that severely
Yeah, so that's
because it's
where we're
gonna be
gonna
the
have.
same AST.
Yeah, at some point we're gonna have to adapt the evaluator to accommodate types and ignore them.
So integer. Oops. Uh,
Type check
A.
abstraction. Oh, the labels. The labels now they are accommodating types as well.
Oh wait, I
So
don't remember how the labels are. Let me see.
the labels are like this, man. Let me pick one without variadics. Here, I found one. Oh man, it's so handy to have these tests. I'm glad we did. I would never be able to remember how to do these things. Oh, we just call argument.
Yeah.
So now you have to have the argument, the
Oh, we don't need the
name.
argument then. We just call it like integer.
Yeah, yeah. Let me check the order though. So the type should be on the right, as far as I can tell. What do you prefer?
Wait. Okay, say it again.
So here, you see here, this,
Uh,
according to the type check abstraction function, this should be
mhm.
the type should be on the right, not on the left. What do you think
Okay.
about that? We can change that. That's totally
Yeah,
arbitrary.
that's fine.
I kind of don't want that because I prefer the other
Because
way. Yeah, we are breaking
yeah,
totally breaking the convention.
yeah, this language is already breaking the code. everything
Not quite yet, but okay.
yet.
Okay,
Okay,
let's go.
so and then we also need the return type
We
for
also need a
this,
return type.
which is bound by this literal thing. So
Uh,
if it evolves correctly, which is determined by the body, that's what I mean.
oh yeah,
So
the body. Yeah.
so it should be integer, the thing. Is that correct?
Yes, I guess so.
Actually, no, right? That should be an arrow type.
Should be an arrow.
Yeah, that's wrong if we're doing that
No, 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 no,
otherwise.
no, no, no.
Because it
Wait, wait,
should
wait.
be
This should be an
in,
arrow. No, we have that. We have that. That's no problem.
do we?
Yeah, it's this.
Oh yes. Okay. Variatic info, so
Variadic?
we don't
Not
care.
variadic in
Who
this
cares?
case? No, no, no.
Who
This should be
cares?
not variadic. Now it's the types of the parameters.
I think it's a list, right?
Yeah, it is a list.
Integer
Integer.
A.
No, no, no. I
Oh,
don't. I think it's only the integer.
the
Yeah,
name.
the
Yeah.
name. And the return type should be also an integer in this case, I believe. If this
That.
works.
Type
uh,
check, function
um,
type check to
oh,
undefined
I think we need to export.
environment.
No,
No, we
it's
need to
just
pass the
one. No,
environment.
it's just one. No, 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 it's just one. No, 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 no,
What?
no. No, 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 don't do that.
Man,
I
we
changed
need to
that.
pass the
No, but
environment.
I
What?
changed that.
Oh, you're loading the prelude there.
Yeah.
Okay. So you're not exporting probably.
No, I already exported it, I think. Now I'm
Type check
exported
one.
correctly. Go.
It
Nice.
works. Okay. I am impressed. Okay. I will go have dinner and I'll be back in a
I
sec.
am impressed.
Dude, what the heck? Anyway, I'll be back.
You guys keep complaining, but we are making progress. I'm pretty certain that at some point things are gonna explode pretty bad, but until that, it's fine. Error. Can I type in this terminal? No, no, I can't. That's not nice. I'm impressed. mm. Ooh, I think this is wrong. That's cool. Press B. Variadic. Oh no, man. We changed the design in the middle of the way. That's gonna be really bad to fix. The evaluator is now wrong, which sucks. Antonio, you still there?
Yes.
Man, do you see here?
Wait. Okay.
Do you see that we are not differentiating between the variadics and the non-variadic parts?
Uh, uh, wall application of abstraction. There is variadic. Address to be. What do you mean?
Like when these are pretty much the parameters that this abstraction is requesting, right?
Uh
This,
huh.
and we are saying it is variadic. Do you like agree that inside here we are not saying, oh, the first one and the second one, they are mandatory, and the third one is the variadic one? We are assuming.
Yeah, there is no need for that. Like it should be always be the last one.
No, but that's the thing. We are not. We are assuming a different assumption doing the type checking.
Ah.
Yeah. Remember that mechanism that Magetta was explaining about consuming the first two ones because they are not optional?
Huh.
That is different, as far as I can tell, is differentiating between the non-optional ones and the variadic ones.
Well, I'm not sure. I didn't pay attention specific to that part, but like what needs to be is the variadic is always the last one.
No, no, no. The variadic will always be the last one. What I'm saying is that let's suppose that we have a function add, for instance. The first two parameters on that is they are obligatory, right?
Mm-hmm.
But that's the thing. I think that we are not we are con- like accumulating all the parameters using the rest, even the ones that are not optional.
Not sure what you mean. And by the way, using the word optional, it's a bit weird because it can mean something else, something that we don't have.
Okay, so let's forget about optional. Let's just talk about variadic and non-variadic. Okay.
Mm-hmm.
Okay. So the first two options, the first two parameters, sorry, the first two parameters of the function add, they are non-variadic, correct?
I don't know. It's a function that you are doing, or
The function add, it is a variadic function, correct? In our language.
what is it? Oh, okay, the plus.
Yes.
Oh, sure, yeah. It has like one argument. It is variadic, right?
Yeah, exactly. But let's
Yeah.
suppose. Oh, wait. So in our language, the plus is one argument, which is variadic.
Well, it should be.
Mm. Then we need to make a test for the evaluator and for the type checking that we have both, like non-variadic and variadic at the same time, because we were imagining the plus in this case.
Wait, what? Can you repeat that?
Look at this example that I'm showing at screen.
Okay.
This is an application of an abstraction which is kind of behaving like the plus, right?
Uh,
In the sense that it has only one parameter, which is
oh,
variadic.
yeah, like that example is the one I was saying that you cannot. Wait.
This is a variadic identity function, man.
Yeah, that doesn't work. That's what I was saying to you. Like, if you don't have things to treat the list, the user cannot use. And if you don't even have the type for a list, then you cannot even test that.
No, no, I agree with that. But the problem that I'm leveraging here is a different problem.
Okay.
What I'm saying is that we should have both in the evaluator and the type checker, we should have a test that it is a variadic function and has both in the parameters non-variadic and variadic at the same time. Because here we have only one case, which is, as a coincidence, is a case where it is variadic and it has only one.
Okay, I agree with that. We should test a bunch of cases, but what is the thing that you are
That's the thing. I'm not certain that our evaluator will evolve this correctly in the other way.
in the other way? You mean like mixing variadic and
Yes,
non-variadic?
yes.
I'm pretty sure we deal with that. We handle that.
So how does that work exactly? It is argument here, I guess, and then we say A, and then argument B here, and then you're gonna have to rename this to C, and this is gonna be the body, which is only variable B, which kind of means that you're gonna have to do something along these lines, I guess. So the C is gonna be 3 and 4, and the A
Wait,
is gonna be
what?
1, and the B is gonna
Those
be 2.
argument and rest are like symbols that we have?
Yeah.
That's weird. That shouldn't be necessary. We know it's variadic, right?
No, we need to have this in order to identify the variadic part. I remember in the evaluator.
Wow, but isn't always the last one, right? If
Oh,
you have
here,
the
see?
info. Yeah, that's very weird, but it's okay.
We can change that. But I just want to test when Magenta is back because I don't have access to the terminal. I just want to understand. So the answer, the final evaluation of this should be the number 2, as far as I can tell.
Yeah.
So it needs to be here and here. No, 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 no. It's not a list anymore. So it's just this, this. Yeah. 1, 2, 3. Yeah. Okay, so this should work. When Magenta is back, we're going to discover pretty quickly. So we have an argument and an argument. I don't actually remember if the way that we did this is actually with arguments like this. I don't even think we have an example. Yeah, application variable. Application using a variable. Oh, but this is an abstraction. Let's see in the eval abstraction. Actually, it's an eval closure as far as I remember. Yeah, so you have arguments. So how does that go with the environment, arguments? What do we have here? No, that's not how. Wait, I'm confused right now. Do we have the keyword argument?
Not a clue.
I I'm having a hard time remembering. I think we only have a variable.
Are you using Ctrl F?
No. Oh, here. Non-variadic names. Yeah, so we are assuming it is an argument, like in here. Okay, so this should work then. Argument A, argument B, rest C, then the return type of this the body of this abstraction should be just variable B, which is in this particular case should bind to 2. Yeah. Yeah, let's see if this works. Which brings us to this, by the way. So now there's the question. So this is gonna be, I don't know, integer A, I guess, and the body of this should be variable A. Variable A, and then the answer should be an integer. This shouldn't be an assert error. So type check abstraction, variadic, integer A, integer rest, variable A, which is the body. So this should be variadic, being a function, like an arrow. The parameters should be integer, integer. And the return type should be integer because we're returning A.
By the way, don't we have those functions for testing that takes a string as the name of the test, as the name of the suite?
What do you mean?
So, for instance, usually we have a string, like a title associated with each test and each like test suite.
Yeah, the way that, I don't know if you can separate. Right now we are just using rebar 3 test as far as I remember. And the way that you do it is that Erlang, at least using rebar, it uses name matching. So if you have a function called type check and you want to make a test suite for it, you just add this.
Okay, but not for individual tests, right?
I have no clue. We didn't go that far because the last time around when we did this, we were just, man, we have an eval and we want to test the eval multiple times. And then we did a bunch of research or something like that, and then we discover, oh, this is the way you do it. And then we're doing the same. It would be really nice to be able to tell, like, rebar 3 test and just test just this, because right now it's testing both. It's calling both. It's calling this one and this one. Whew. Yeah, but we're pretty close to 2 hours here, so I think we're gonna wait for Mageta, and then he's gonna execute the tests, and then if it doesn't work, I don't know, maybe the fix is quick, and then next Friday we continue this fun adventure. I'm having fun. And I will definitely read the Wikipedia page for next session. Like, read this. Okay, we can continue now. Mageta is back. So I added more tests, and apparently 5 of them fail. I suggest to us to fix them if they are quick, and then we end for today.
Okay, we have 5 failures, so let's see one by one.
Can you? Yeah.
So first one, assertion error.
Yeah.
Okay, it's an abstraction, not variadic, blah blah blah. Expected exception, blah blah blah, but got value false.
This is wrong because because we are expecting to be
Oh
variadic,
wait,
but the abstraction is not.
wait,
So this
wait,
means
wait,
the
wait,
type
wait.
checking is wrong.
Where's the abstraction? It's this one, right?
Yeah.
Wait, yeah, you
It's
have
not
like equals
assert.
there.
So it's not assert error, right? It's just
No, it
assert.
is assert error. It is assert error indeed.
Shouldn't
Because
it
this is
be
wrong.
equal?
No, this is wrong.
What? Dude, what do you want to check here? You want to check if this types returns this.
Oh, that's true. That's true. My bad. Let me help you with that. No, a bunch of them will
Uh,
fail, man.
yeah,
Because
but it's still wrong. Not variadic. Expected true got false. What the heck?
what the fuck is that?
I don't know, man. Just sounds. It just goes out.
Yeah, the equal would help with that debugging, right? Because he would have like better stuff on the expected and God.
Wait, but can we all agree that it was expecting true but got false?
Yeah, but probably it's a pattern match.
That's
It's wrong.
No, that's
Abstraction.
correct. No, wait, go back, let's read that error again. That's I
like, but that's always the
Here's
case,
an error,
Lemos.
man. It's wrong.
no. It is the purpose is to have an error. Pay
What?
attention. The abstraction is a not variadic, correct?
Yes.
Look at the after the rabbit. Do you see that we have a function which is variadic?
Oh yes.
So this should be different. That's my intention with the test.
But okay, like that's not a good test, I guess, because
No, I'm
this
testing.
just gets propagated.
Yeah, that's exactly the property that I'm testing.
Okay, but like,
I'm
So
testing.
assert not or
Yeah, assert not. I think assert not is the one. I think we do have this function, by the way.
Yeah,
Assert not equal, by the way.
yeah, assert not worked.
Oh, nice.
Yeah, it's
Or actually, no, it didn't. What the heck?
Are you sure?
Yeah. So let's try the equal.
No, no,
yeah,
no.
but
But no,
equal has two arguments.
equal has two arguments. You have to put, instead of the rabbit, put a comma. Yeah.
Still four failures.
No, but it's a different one. So it worked.
No, it's not a different one. Expected true, got
Yeah,
false.
but look at the assertment. We are asserting something totally different now. It is the
What?
same thing. Let's change all of those to not equal because all of them should fail. So not equal.
But dude, Viz is failing, isn't it? Or is
No,
it
I
another
don't
thing?
no,
think
no.
so.
It's not failed. That's not the one.
Okay.
Let me just
That's why
this.
you don't test, man. If you test, you find this kind of stuff. Find this kind of stuff. Like you don't want to do that.
Let's try now. Save and try to test again, please.
Now there's
One,
just one failure, which is this.
which is the
Didn't
last one.
find a variable. Didn't find a variable a.
Didn't find variable a, which is
The body of the crap.
rather.
And I just noticed. No, no.
Oh, that's. I think that's a problem with our implementation then, because I think this is correct, right?
I think so. Is that how we are evaluating a variable? Let's see. Oh, dude, we're not inserting the variable in the environment. Like, are we?
No, we need to add that to the environment. No, wait.
Let me
No, no, no,
see.
no, 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 that's correct. Go back, please, Magetta. The variable a is the body of the abstraction, correct?
Yes.
And the thing in the middle is the parameters, right? So it's like lambda a and the variadic part, because this is variadic, and then the return type, the body of this abstraction is a. So this should be added to the environment when we like type check the body of the function, correct?
Yes. Yes.
Yeah. So yeah, so it needs to be a error with our implementation.
Length. We're not changing. Oh, we are. List fold L labels with them on the environment. So we're just trying to find, but we're not adding anything. Do we need to do that here?
We are on the function.
Yeah, we are doing that with the fold, man. The fold is adding.
Oh, here. Maps, but. Oh, this is very trash. Yeah, I see. This is an accumulator, blah, blah, blah. Okay.
Wait, is this put immutable? Like he actually returns the.
There is no mutability, man.
Oh, nice.
There's no mutability. That's correct. Hmm.
I don't know, man.
Let's use our very good friend printing. So after, let's print the environment.
Yeah.
So
Wait. Why don't you do that before lamp? Instead of assert, you do assert equal, and then he will tell you what he got.
that's actually a good debugging strategy. Let's do that. Equal, and instead of the
Need to
rabbit, we put
change my
comma.
keyboard mode.
Go, Magetta, go.
Oh, you don't want to change there. You want to.
Yeah, no, just comment this for now and just test. Okay. Yeah, that didn't work. Oh, that didn't work, Nathan, because we are raising an exception, man.
Oh, fuck.
Yeah, so we need to add the
I love
print.
this, man. I love this. Like,
We have 25 dots and the last one fails, so you have an
yeah,
F at the
imagine
end.
if you have like oh, it's dot like 16. Oh, good.
Oh, no.
Dot 16 is failing. Nice.
Yeah, but we can see what was the message of the failed, then we know where it failed.
I don't think so. But not the no, not the get
Hmm?
to
Like,
test
don't we
this.
have text on, or like,
This. So this is the environment. We have integer pointing to rest. That's very
What?
wrong. Yeah. No,
yeah,
no, no,
oh,
no,
the
no.
opposite.
We swapped the order. It's the type.
Oh, that's true. We swapped the order.
Yes, that's right. Okay.
Okay, so let's remove the print and let's commit and call it a day.
Dude, this it went very smooth. Like I wasn't expecting
We
this.
didn't test everything, just to like make sure. We
Oh, we
have more
still
tests
need
to
to
do.
test an application. Let's test an application. Let's
Okay.
make
And
something
testing
happen.
also doesn't assure like a whole lot.
Well, we
It is a
can be
first
sure
step.
of
It is a
anything.
it is a step in the right
No,
direction, I
no,
think.
yeah, it's better than not
This entire
testing.
project is without any sure of anything.
Oh no. I
What
agree,
the
Nathan, that it's not because it's passing the test that is correct, but at least we are writing tests that make sense for us, and it is working. So
It's useless, man. Just accept the tests
that's
are useless.
useless.
Just accept the tests are useless. They're just like lies programmers tell themselves. So this is the arguments, right? And how are the arguments passed? Let me see on the evaluator test. It's literally just a list of garbage.
Yeah, but we need to remember that we are changing the AST of the type checker is using is slightly different than the one that the evaluator is using, at
Yes,
least for the moment.
sir. So it's gonna be this. Let me actually do this. Let's do. Oh man, let's do this. I think it's better. Maybe not better, but yeah, whatever. This. This and literal integer 2. Nice. And then this should evolve into an integer. Is that correct? Or am I daydreaming?
Just a sec. Okay.
Let's hope not. Apparently I am. This I don't know where
Undefined.
it's
Undefined, it's saying there.
undef, but what?
Something along the way, it's undef.
Lists length integer empty.
Periodic. Integer 2.
Because there are two things, right? Here.
Yeah, that's true. We have two things there.
Oh wait. Okay, and the body is
Uh,
just this. Let me just indent it properly.
what is the bug?
This.
We have a literal. Yeah, the answer should be integer. Yeah, that's correct. I don't understand. Um,
So
okay.
there's something leaking here. Leaking
Okay,
or like
let's
being
read type
filtered.
check application. Uh, here. Okay, so you're doing a variadic one, so it's gonna do this.
Yeah, so it basically splits. Let's see if it's splitting correctly. That's
That's
a
that's a
good
good
check.
test.
You know what to do, Lemus.
What is the episode? That's why we need better keyboards. That's why we need better keyboards, man. That's why.
Yeah, let's print just this two, and then we copy and do the same for the non-var. Non-var sig and visig.
Let's go. Okay, is it printing? No,
Cool, we didn't even reach here.
that's not cool. Let's go to type check. Type check. Type check with environment, application, abstraction, and
Oh wait, do we
arguments.
have a third case for this match?
What do you mean
Uh,
Oh
third
wait,
case?
but
no, right? Variadic or not? That's
Yeah,
not a possibility.
okay.
periodic or not. Okay, I'm curious what
But then we
exactly.
are having the error of match and not a one of our own, right?
Line 79.
Yeah, so I think it's here. Oh man, is that it?
Wait, we don't. It's not inside lists.
No. Yes, it's printing.
Okay, integer,
Yeah,
integer, integer. Is that
yeah.
correct?
Yes, that is printing non-var type args, var type args, and then it's printing the signature without the variadic part, and then signature with the
Okay, so we have
variadic
four
part.
integers, which is correct.
Yes, that's right.
Okay, so
And just a split. So we can even change it here. Let's change to make it more clear. Let's
no,
change over
that's oh,
the
yeah, there.
other one. Here, let's change this dude to a string. So it should be assert not equal in this case. Okay. So, and then here we go for if the thing is the same
As we are
as the type
receiving.
args, which should pass, like we should pass just fine.
No, this shouldn't pass, right? Because the type of the args are now a string. Or am I going
No, no.
crazy?
This is the non-variadic part.
No, this is the variadic part. What?
This is the non-variadic part.
Oh,
I
okay, sorry.
modified the variadic.
Oh, okay.
So, and then if it goes from here, then we try to do lists all to check if all the elements inside the other garbage represent uh, the rabbit operator returns true. If they all are true, then we return the return type. I don't see why this is wrong now.
Wait, but are we printing type something? Scroll up in the terminal, please.
Oh, here.
Yeah. Oh, we are. Okay, so
Type of the variadic argument P does not match variadic type of the signature and abstraction.
yeah,
Oh
so
wait, so that's right.
is that right?
No, wait, because here's the thing. Type of variadic argument in P, we gotta fix that probably, does not match variadic type of the signature in abstraction. So the argument on that receives the variadic shit on the
Man, we are
abstraction.
interpreting our own error message. That's so cool.
Yeah. It's not complying with the argument that you are passing. So,
But this is the case, right?
but wait, like that's why I'm confused because what we are passing here is a literal integer
It's
and
string.
a literal string.
But the
So
abstraction is expecting an integer and an
this,
integer.
yes, but it's expecting this. So this is right to be wrong. That's what I mean.
In this case, yes, I agree with
In
that.
this case. But then why is the assert error not working?
We are not using assert error, I believe. I think we are using just
I think
assert.
it's the assert not equal.
Assert not equal. Oh, that's wait. Yeah, that's correct. We are
Oh, that's an exception, man. That we shouldn't. We should assert like,
oh, error.
yeah, assert error.
And then we just put a y label here. Yeah, test now.
No, man, that's so trash.
That's fine.
No, it's not, man. Okay, and then I don't like this though, but because we're not really testing it, right? We're just like, okay, any error, like,
I agree. I agree. That should be we should do this better.
equal.
Yeah.
So now we should remove this, and
Yes.
then here, dude. Now this should work. Integer assert equal. Oh, equal to what
Yeah,
tomorrow?
exactly. I think it's integer, right?
Integer.
Hmm.
Okay.
20. Okay. Same error.
At
We had an
the
error
end,
this time,
yeah.
but now this
But
is correct.
yes, now it's matching.
Okay. So I think this needs to mean that we have a problem. Let's print the list all.
Yeah. I bet we are gonna suffer more in the future.
Man, you are saying that all the time, and as far as I can tell, it's not that bad.
No, man, like, we are gonna suffer in the future. Because like up until now, things are still small, man. When it starts to grow, and we're just gonna get lost.
I was assuming that all, like for all the time, and as far as I can, and for now it's fine, at least for now.
Yeah, you know the drill. Okay,
Go.
and then here we match X.
False.
False. Why
Interesting.
false?
Oh, they're
var
wait. Var.
var type sig and var type args.
They're all integers at the end of the day.
They're all integers, yes. Oh
Huh?
wait.
What?
Oh wait. Should we? Yes, that's right. We should iterate over the arguments, right? And checking if they. Oh man, of course.
What?
Of course. You're so stupid.
What? Can you tell me?
This is a list. This is like this.
Okay, that's true.
So we should. How do we unpack lists? Do we have any garbage like lists? Oh, we can just do first. Uh, take no. Dude, just return me the thing. Like, I don't want a pattern match to return that, please.
What about doing this, man?
Env.
No, no, no. What about doing variadic? No. Var type sig. Var type
Oh man, these
sig,
days.
and then we can just do this.
Yeah, okay. Smart solutions for a smarter age. Okay, so we have everything working. I'm very surprised. I will just commit this.
Wait, wait, wait. I'm changing the code back to the. Can you test again, please?
Yes, sir.
Nice.
Working.
Yeah, commit that.
So let's do it.
We should also. Do you see the Docker file that?
Yes, we didn't. I didn't modify that. I just remove it for now. Is
Yeah,
this
but we
necessary?
should make the GitHub action to trigger the tests.
Yeah. Oh, it doesn't show you here, man. Can I just add it here?
I think so.
Let's do the zoomer shit.
I will send the email in chat.
Eduardo. I
Actually,
think we can stop.
I